New evidence that an extraterrestrial collision 12,800 years ago triggered an abrupt climate change for our Earth. This is on The Conversation by Christopher Moore, archaeologist and Special Projects Director at the Savannah River Archaeological Research Program and South Carolina Institute of Archaeology and Anthropology, University of South Carolina. So what kicked off rapid cooling of Earth 12,800 years ago? In the space of just a couple of years, average temperatures abruptly dropped, resulting in temperatures as much as 14 degrees Fahrenheit cooler in some regions of the Northern Hemisphere. If a drop like that happened today, that would mean an average temperature of Miami Beach would quickly change to that of current Montreal, Canada. And let me tell you, as a former Montrealer, you don't want to have winters there. They were terrible. We had more cold there than they had in Anchorage, Alaska. Now, layers of ice in Greenland show that this cool period in the Northern Hemisphere lasted about 1,400 years. This climate event, called the Younger Dryas by scientists, marked the beginning of a decline in Ice Age megafauna, such as mammoth and mastodon, eventually leading to extinction of more than 35 genera of animals across North America. Although disputed, some researchers suggest that Younger Dryas environmental changes led to a population decline among the Native Americans known for their distinctive Clovis spear points. Conventional geologic wisdom blames the Younger Dryas on the failure of glacial ice dams holding back huge lakes in central North America and the sudden massive blast of fresh water they released into the North Atlantic. This fresh water influx shut down ocean circulation and ended up cooling the climate. This is a lot of what's going on now, isn't it? With the melting Arctic, the fresh water inundating, coming into the oceans, into the Northern Atlantic, and causing a change in the Gulf Stream currents pathways, and causing, of course, polar vortex coming a lot more south, giving us our extreme, record-breaking cool and freezing temperatures, devastating our crops. Now, some geologists, however, here described to what is called the impact hypothesis, the idea that a fragmented comet or asteroid collided with our Earth 12,800 years ago and caused this abrupt climate event. Along with disrupting the glacial ice sheet and shutting down ocean currents, this hypothesis holds that the extraterrestrial impact also triggered an impact winter, quote-unquote, by setting off massive wildfires that blocked sunlight with their smoke. The evidence is mounting that the cause of the Younger Dryas cooling climate came from outer space. My own recent fieldwork at a South Carolina lake that has been around for at least 20,000 years adds to the growing pile of evidence. Now, what would an Earth impact leave behind? Around the globe, scientists analyze ocean, lake, terrestrial, and ice core records have identified large peaks in particles associated with burning, such as charcoal and soot, right at the time the Younger Dryas kicked in. These would be natural results of the cataclysmic wildfires you would expect to see in the wake of Earth taking an extraterrestrial hit. As much as 10% of global forests and grasslands may have burned at this time. And looking for more clues, researchers have poured through the widely distributed Younger Dryas boundary stratigraphic layer. That's a distinctive layer of sediments laid down over a given period of time by processes like large floods or movements of sediment by wind or water. If you imagine the surface of the Earth is like a cake, the Younger Dryas boundary is the layer that was frosted onto its surface 12,800 years ago, subsequently covered by other layers over the millennia. In the last few years, scientists have found a variety of toxic impact-related materials in the Younger Dryas boundary layer all over the globe. These include high-temperature iron and silica-rich tiny magnetic spheres, nanodiamonds, soot, high-temperature melt glass, and elevated concentrations of nickel, osmium, iridium, and platinum. While many studies have provided evidence supporting the younger Dryas impact, others have failed to replicate evidence. Some have suggested that materials such as microspherules and nanodiamonds can be formed by other processes and do not require the impact of a comet or an asteroid. A view of 12,800 years ago from White Pond. In the southeastern United States, there are no ice cores to turn to in the quest for ancient climate data. Instead, geologists and archaeologists like me can look to natural lakes. They accumulate sediment over time, preserving layer by layer a record of past climate and environmental conditions. White Pond is one such natural lake, situated in southern Kershaw County, South Carolina. It covers nearly 26 hectares and is generally shallow, less than 2 meters even at its deepest portion, that is 6 feet, at the deepest depth. Within the lake itself, peat and organic-rich mud and silt deposits upward of 6 meters thick have accumulated, at least since the peak of the last ice age, more than 20,000 years ago. So in 2016, my colleagues and I extracted sediment from the bottom of White Pond. Using 4-meter-long tubes, that's about 12 feet long tubes, we were able to preserve the order and integrity of many sediment layers that have accumulated over the eons. And based on preserved seeds and wood charcoal that we radiocarbon dated, my team determined there was about a 10-centimeter thick layer that dated to the younger Dryas boundary from between 12,835 and 12,735 years ago. That is where we concentrated our hunt for evidence of an extraterrestrial impact. We were particularly looking for platinum. This dense metal is present in the Earth's crust only at very low concentrations, but is common in comets and asteroids. Previous research had identified a large platinum anomaly, quote-unquote, widespread elevated levels of platinum consistent with a global extraterrestrial impact source in younger Dryas layers from Greenland ice cores as well as across North and South America. Most recently, the younger Dryas platinum anomaly has been found in South Africa. This discovery significantly extends the geographic range of the anomaly and adds support to the idea that the younger Dryas impact was indeed a global event. Volcanic eruptions are another possible source of platinum, but younger Dryas boundary sites with elevated platinum do not have other markers of large-scale volcanism. More evidence of an extraterrestrial impact? In the White Pond samples, we did indeed find high levels of platinum. The sediments also had an unusual ratio of platinum to palladium. Both of these rare earth elements occur naturally in very small quantities. The fact that there was so much more platinum than palladium suggests that the extra platinum came from an outside source, such as atmospheric fallout in the aftermath of an extraterrestrial impact. My team also found a large increase in soot. It's indicative of large-scale regional wildfires. Additionally, the amount of fungal spores that are usually associated with the dung of large herbivores decreased in this layer compared to previous time periods, this suggesting a sudden decline in Ice Age megafauna in the region at this time. While my colleagues and I can show that the platinum and soot anomalies and fungal spore decline all happened at the same time, we can't prove the cause of why this happened. The data from White Pond are, however, consistent with a growing body of evidence that a comet or asteroid collision caused continental-scale environmental calamity 12,800 years ago, via vast burning and a brief impact winter. The climate change associated with the younger Dryas megafaunal extinctions and temporary declines or shifts in early Clovis hunter-gatherer populations in North America at this time may have their origins in space. This is a beautiful little diagram of what they've come up with. The White Pond sediment core is like a timeline of the stratigraphic layers. What researchers found in each layer provides hints of climate and environment at that time. Okay, this is what we have here. 13,400 to 12,800 years ago. This is supposedly the native North American Clovis culture here. As you can see, they had to move because of the change in weather. The megafauna, the mastodons, the mammoths, the sloths. This is about the same time. And going up, abundant spores they found in the sediment. This is supposedly the core that they found, that they extracted from the White Pond bottom. Okay, so going up, we had soot. Spore decline, is that the extinction perhaps? And the soot anomaly from fires, from asteroid or celestial comet, some kind of a celestial body, impact, burning impact, younger Dryas. 12,835 to 12,735 years ago. And this is the sediment from the last 10,000 years, basically up to the top. I've always asked myself, how is it we have so much buildup of sediment? Where does all this sediment come from? Worldwide. It's as if there's, every year, it's like a growing tree. The earth is growing with all this sediment. Where is all this sediment coming from? Well, we know that we get particles from asteroids that come and dissolve, of course, burn up in our atmosphere. We don't see them, but they're dust particles. We get tens of tons of this every single day. And from what they recently found, we also get hit by interstellar comets. 25,000 a day, carrying 20 to 40 tons of water. Clean, clear H2O. But they don't hit our atmosphere. They hit our magnetosphere, and that's where they blow up. And that still comes down to us, though. So every day, every year, we get an accumulation of soil and water from our solar system. That's amazing. Amazing. So this is a wonderful image. This is the spores that they found before the younger Dryas from the dung of the megafauna, the mastodons, the mammoths, the sloths, various spores as you can see here. And that stopped with the impact. And from one of the previous articles that I did a video on, that's how the Hudson Bay of Canada, for those of you who don't know, Hudson Bay is just north of the Great Lakes. That huge circular bay, they say, was formed at that time at the younger Dryas impact. The red dots are asteroid impacts here in North America, and Hudson Bay is that circular water body around 2 o'clock. Amazing. I'll leave links below for you for this on the conversation. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Capota, and we also help the young generation with university tuition and the community around our church. Thank you.